Hey guys, so I'm going to go ahead and go over this homework 9, which is about solutions and concentrations. This is for the 30th of October, if you forget when we did this. But for this first question, what I look for first is essentially what formula am I going to be using. I know I see this right here, this V over V, that means I'm going to use the volume over volume formula. So I went ahead and wrote it down. And then what I'm going to do next is fill in these spots with whatever they give us. So we know we have a cleaning solution, it contains 2%. So I know that we have this percentage V over V right here. So I'm gonna go ahead and just write it all out in the middle. We have 2% with the V over V. That is equal to, now remember we have our fraction times 100. We're trying to figure out what volume of ammonia is needed to prepare 20 liters of this solution. So right here, they're telling us that our solution is 20 liters. I'm gonna go ahead and put 20 liters on the bottom because the volume of our solution goes on the bottom. So all we're finding right here is whatever is on top. We don't know what this is. I can call it X, you can put a question mark, whatever you want there. And this is where some people kind of do their math in different ways. They might go in different directions. For me, I like to get X by itself on one side. Some people will have like fractions on both sides and do cross multiplication. I can do both ways, but for me in my style, I like to get X on one side. But as long as you figure out a way to figure out what X equals, totally fine. So first I'm gonna get X by itself. So what I'm gonna do next, I'm gonna multiply both sides by 20 to get rid of this 20 on the bottom, okay? So both sides are gonna be multiplied by 20. That means we now have 20 times 2 on the left equals X, or you can say 100X, okay? We still need to get X by itself, so I'm gonna go ahead and divide both sides by 100. That's how we get rid of anything that's being multiplied. Now it's gonna end up looking like this. There's a shadow on the left, okay. 20 times 2 over 100 equals X. When you put this in your calculator, make sure you're doing the top numbers in parentheses so it doesn't mess it up. Okay, so what you should get is 0.4 0.4 liters equals X, or it's the volume of ammonia, which is the solute. Next we have 2. So this is about same process, but we're doing mass over mass. Just like the volume over volume formula, it looks pretty much the same. So the mass over mass percentage is equal to the mass of the solute over the mass of the solution. Times 100. Okay, so we're just gonna fill in the blanks. We know a solution is prepared by dissolving 15 grams of glucose in 85 grams of water. Some of you might be thinking, how do I know what's the solution and what's the solute? Usually whatever is smaller is the solute. You're putting the solute with the solvent to make a solution, essentially. So in this case, glucose is our solute. It's a smaller amount. So we know we're going to fill this in on the bottom. We know 15 grams of glucose is going to be on the top because that's the mass of the solute, divided by 85 grams of water. So big question today, is the bottom number 85 or is it 100? I'm thinking that it's going to be 100, so 85 plus 15 equals 100. I'm adding both of these together because it's not saying 85 grams of solution. It's just saying 85 grams of water. We have our solute and solvent. They come together, make a solution. So I have a really strong feeling that the bottom number is 100 grams. I asked Dr. Wiegand today, and she said, thanks for letting me know. I'll send you the key, and have yet to get it. Of course, we don't know this percentage, so that's what we're finding. I put X there. All we have to do is just math, okay? So you do 15 divided by 100, or you know, oh, this crosses out, it's gonna be 15. So our percentage is going to be 15%. So essentially 15% of our solution is glucose. So next we have a nursing question. A nurse needs to prepare 250 milliliters of alcohol solution with a 20% volume solution concentration. How much pure alcohol should be used? So this is a volume over volume. I'm not going to rewrite the formula every time, okay? So we know we have our 20%. So we know our percentage already. V over V. So that means 20% of the solution is pure alcohol. So we don't know how much alcohol there is, which is the solute. We know that there is a total of 250 milliliters of solution. And it's gonna be multiplied by 100. Honestly, I feel like this equation stuff is kind of, or this formula is kind of complicated. You could just be like, oh, we know 20% of this solution is this, so just do 20%, like 0.2 times that, and you're gonna get your answer. Or we can just, follow this formula if you want. There's many different ways you can do this math stuff, guys. So I'm gonna get X by itself. I'm going to show you all the steps again. Multiply both sides by 250. And I usually do it all in one step, but I'm breaking it down so it's not like what is going on. So now we have 250 times 20 on the left equals 100x, which then to get rid of that 100, we're going to divide both sides by 100. So our left side is going to be 250 times 20 divided by 100 equals x, which then gives us, put that in the calculator, 50 milliliters of pure alcohol or ethanol. They basically made Everclear, almost. The doctor orders a 5% mass over volume saline solution for intravenous. Before I move on, let me show you what I meant when I said I can make this less complicated. We know that 20% of this solution is however many of pure alcohol. So all you could do is just do 250 times 20% as a decimal. You just do 20 divided by 100. It's going to be 0.2. Then you'll just get 50. Basically, in other words, what's 1/5 of 250? 50. So that's just another way to think about it, if you know what I mean. For our doctor orders 5% mass over volume saline solution for intravenous use. How many grams of sodium chloride are needed to prepare 500 milliliters of the solution? So mass over volume is pretty much the same thing we've been doing, the same kind of formula where we do the fraction times 100 equals the percentage. So we know the solution is 5%. 5% of the solution is NaCl. Okay, I'm going to do the hard side and then the easy way because it's the same kind of thing. We know 5% of it's NaCl. We know the total amount is 500. And we don't know anything else. We don't know what that is. So I'm going to go ahead and get X by itself. That's going to look like this. Okay, I'm just skipping ahead a couple of times. It's the same steps I did here. It's the same steps I did for number 2 as well. So then you do it again, put that all in your calculator correctly, you should get 25 grams of NaCl. That's how much of the solute we have. Or you could do it this way. We know 5% of this solution is, well, maybe we can't. Let me see. Let me do it on my phone really quick. If we do 0.05 times 500, then you have to convert milliliters to grams, which is a whole other thing. Okay, no, it works. So we know 5% of this is how much grams of NaCl we need. So you could totally just do 5% in decimal form is 0.05. I got that by doing 5 divided by 100, okay? So you can take that percentage, multiply it by the total volume to be like, okay, we only want to know what 5% of this volume is, you're going to get 25. That's another way of doing it, if you know what I mean. 5, a nurse needs to prepare 500 milliliters of a 0.9% saline solution. Interesting. Okay, I was just thinking about this in real life. So this is going to be a molarity question. Molarity formula. We have the moles of the solute over the volume of the solution. And that will be in liters. I gotta go with the liters. So I'm gonna separate this into 2 different sides. We're gonna find our moles first. So moles. So they don't tell us how many moles we have. We have to figure out how many moles of NaCl we have, because NaCl is our solute. Saline solution is our solution, okay? We know we have, well, I'm not gonna do the volume yet. I'm gonna find the moles. So how many moles of NaCl? We'll figure it out first, okay? From what, remember with moles, we can convert, we haven't even gone over moles in workshop, which is crazy. Moles can convert to the molar mass or Avogadro's number. So keep that in mind. So I'm like, we don't have the mole, but we have something in grams of NaCl. I know that if I find NaCl's like total mass, you multiply it by its molar mass, I can get mole. So that's the direction I'm thinking of. You might be thinking, where do I start? Just know we can convert grams to moles, okay? So that's how I'm going to figure out how many moles I need. So first I'm going to be like, okay, how many grams of NaCl, how many grams of this solute do we have in this solution? They don't tell us. You might have a question that does tell you, so just make sure you watch for that. So we don't have 0.9 grams of NaCl in this entire solution. We have 0.9 grams. We have 0.9 grams of NaCl per 100 milliliters. Okay, we don't have a 100 milliliter total. We have 500 milliliter total. So we have to figure out, okay, how much do we have in this total solution? We're going to multiply it by 500 milliliters. So then now they cross out. And if you do that, you should get 0.9 times 500 divided by 100. You should get 4.5 grams of NaCl. And now we have to convert this mass into moles using the molar mass. So we're going to do second step, 4.5 grams NaCl times, they give us the molar mass, thankfully. So we have grams, we're going to put grams on the bottom to cross them out, moles on top. So we only have 1 mole per that many grams. And if you don't know how to find the molar mass, it's just all of the masses of the elements in this compound added together. It's 58.44. So essentially you're just doing 4.5 divided by 58 and you should get 0.06. 0.077. So now we have our top number. Now we need to find our bottom number, the volume. It's not as bad. We know the total volume is 500, but we need our volume in liters. So you just have to convert 500 milliliters to a liter. The answer is going to be 0.5. If you can do it in your head, that's great. If not, if I like think about like when I ask any of you guys in class and you hesitate, try it like the conversion factors. There's 1,000 milliliters in 1 liter. Remember that like that metric, the base. Like, I never really talk about how important it is to know this. I think this is micro and then nano. Like, you use this the entire semester, and like you really do, and it's important to know because if you get this wrong, then the whole thing's going to be wrong. So our volume is 0.5 liters. Now, final. Therefore, we know our top number is this. Divided by 0.5, we get 0.154 molarity, okay? Last two questions. Okay, 6 was a very interesting one. I went over like the slides from one of the students that I had today to see like, okay, what did she teach y'all? She did not go over anything with dilution. This is more of like, okay, you kind of have to use math to figure this out. It's like an ACT question where it doesn't, you can't really use a formula. I mean, at the end, I find a formula I can use, but it's not that simple. So I'll try to explain this to the best of my ability. So we know we have two different solutions, a 2 molarity solution of potassium chloride, and we have a 0.5 molarity solution as well. So we have two solutions, okay? This 2 molarity solution, remember molarity is equal to the moles, which I'm gonna do that as the moles over, and we don't know this bottom number. We have a 2 molarity solution, and we're going to dilute it. That means we're going to add some more whatever solvent we're using. Most likely, if we have potassium chloride, we're just going to add water or something else. So the nurse is going to dilute it by adding some more water, whatever, to prepare it to become a new solution. So the new solution is a 0.5 molarity. That means it's less concentrated. It's not as concentrated with potassium chloride. We know that, okay, we know that it has 250 milliliters of solution. Remember, I'm just rewriting the molarity equations. These are not written in liters, but I'll worry about liters at the end. So essentially, remember, these are two different solutions, but what makes them different? The only thing that makes these two things different is that one has more solvent, so it's just a bigger solution, making this one less concentrated. What is the same in both of these is the moles. It's like saying I have 1 cup of water with 1 tablespoon of salt. I'm going to now add a half cup of water to make it more diluted. That's what I'm saying with these moles. They still have the same amount of potassium chloride in each. This one is just more diluted because they added more water. So what I'm trying to say is, like, hold on, let me flip to the next page so I can make sure I'm following along with my notes. So if we cross multiply and get this mole by itself, so if we multiply both sides by x, we're going to get 2m times whatever we need to get. We know that this is a common number. We know that's the same on both sides. This one as well, 0.5 times 250 equals that same number on both sides. Technically, both of these things equal the same thing. If they both equal this, then they both equal each other, okay? And what I mean is like this equals this. Because if they both equal, for example, if they both equal 1, that means they both represent 1, and then they equal, or they're the same thing. So one way you can do this is do it like this. 2 molarity, we don't know what x is, equals this right here. Because they equal the same thing, they must equal together. Equals 0.5 m times 250 milliliters. What this also looks like is we're just doing m1 times v1 equals m2 times v2. I was about to sneeze, okay. So all we're doing now is just getting x by itself, okay? Okay. And I'm gonna go ahead and finish this before I get on to the next step and make everything more confusing. So to get x by itself, we're just gonna divide both sides by 2 so we can get rid of this 2m. This is gonna be divided by 2m. So now we have x equals 0.5 m times 250 mLs divided by 2m. Put that in the calculator. You should get 62.5 milliliters. Or, I mean, if we're dealing with molarity, it's supposed to be in liters. So technically, if you convert this to liters, you're just dividing by 1,000. 0.0625 liters, okay? I don't know which answer she wants, but both are fine with me right now. Or you can do it like this. You see how we can figure out what the mole number is over here? We can find that mole number, plug it into here, and then find x. So let me show you what that means. We're gonna find what this mole is using this newly dilated solution. So we have 0.5 m equals mole, whatever this is, over 250. If we get the mole by itself, we just multiply both sides by 250. So now we have 250 times 0.5 is just 125. And then we're going to get, that's our new mole. So that means this is 125 mole. So now we take this number, plug it into this one. So we have 2m equals 125 mole over x. And the way you can get x by itself, it's a couple steps. So remember, we have to multiply both sides. There's a way you can like flip this over and flip the other side, but I don't really remember that. I don't want to mess this up and make this too long. I'm going to multiply both sides by x so I can get x out of this denominator. So now we have, multiply both sides by x. Now we have 2 molarity times x equals 125 mole. We need x by itself, so we're going to divide both sides by that 2m. And now x equals 125 divided by 2 is 62.5. And that should be in milliliters, but yeah. Or you can put that in liters. Lastly, a patient requires an IV infusion of 1 liter of glucose solution with a concentration of 0.5 molarity. How many grams of glucose are needed to prepare the solution? So we know our concentration is 0.5. This is a molarity question. So I'm going to set it up like a molarity formula. We know our bottom number is 1 liter. We don't know this top number. We don't know the moles. So, and they're like, okay, what's the or how many grams of glucose to solute are needed? We're going to find that by first figuring out how many moles we have and then converting the moles to the molar mass 1, I'm going to get this by itself, this x. All we do is get this 1 liter, so we're basically multiplying both sides by 1 liter, which is basically the same number, so we know 0.5 is how many moles we have of C6H12O6. So we're just converting 0.5 moles into grams using the molar mass. So the molar mass of glucose, we're going to put mole in the bottom to get rid of that, right? Molar mass on top, 180. 0.5 times 180, that's just saying what's half of 180. Or you can put it in your calculator. It's going to be 90 grams, all right? Oh gosh, that was, okay. All right, that should be the entire worksheet. Next week we'll work on pressure conversions and gas laws. There's my cat. All right, I'll see y'all.